So now we're looking at question 6 of homework 13, and here we're given a meter long stick, right? This is 0 all the way to 1 meter, and we cut it at 2 points, and this could be x or y, or this could be y or x. I've just put these randomly. They're uniformly and randomly chosen from any one of these points. So x and y might be on the same point. X might be 0, y might be 1, even though so they don't have any specific order, but I've just chosen these 2 points, right? And we need to find the probability that these 3 portions of the stick actually can form a triangle, right? So first let's look at case. Let's look at this in terms of cases. What if first x less than y? We can say less than equal to, but since we have any point which is chosen randomly from 0 and 1, we have infinite number of points. The probability of x being equal to y is actually going to go to 0, because you have infinite number of points, and the probability that 2 values are the same out of those 2, that both x and y are exactly the same, is actually going to be 0. So we can put less than, equal to, less than. As long as we have the 2 cases are complementary of each other, it doesn't matter, and the equal to sign really doesn't matter in terms of how we're going to calculate a probability. So now we have and the 2x is less than 1. Even that doesn't matter. Even if x is equal to 1, it wouldn't make a difference, because getting exactly 1 when you randomly choose any point from 0 to 1 is going to be 0. Probability of getting that is 0. So now let's look at this. Okay, let's just say x is less than y for now, and we want to find in what cases can we pick an x and a y such that x less than y, and we can actually form a triangle with the 3 pieces. The 3 pieces are going to be, piece number 1 is going to be from 0 to x, right? Because x is less than y, we're going to have 0 to x, which is of length x meters. I'm not going to say meters. I'm actually going to note this out and say x minus 0, which is equal to x, right? That's the length. 2 is we have y minus x, right? Because we have, I should probably write this out. This is x, this is y, this is 1. So we're saying x less than y, right? So this is x and y and 1. So the first piece is this. This is the first piece. This is the second piece. And this is the third piece. First piece is x minus 0. Second piece is y minus x. Third piece is 1 minus y. So these are the 3 pieces. Now, how do we relate 3 sides, or the length of 3 sides which we have of a triangle, together to actually get a triangle? If it's a valid triangle, what is the relation connecting each of the 3 sides? Well, it's the triangle inequality, which states that sum of 2 sides is the sum of 2 sides is always going to be greater than the third side. Greater, it's strictly greater. If it's equal to, then we're not going to have a valid triangle. So we need. But again, the greater than, equal to, or greater than, strictly greater than over here doesn't exactly make a difference, because the probability of getting exactly equal to or something is going to be 0. So we don't need to bother with that too much. And I'll explain that in a little bit more detail a little later. The triangle inequality. Now let's try to apply the triangle inequality to the 3 side lengths which we have. So we know that x plus y minus x has to be greater than 1 minus y. This implies x and x get cancelled, y goes to one side. This implies 2y greater than, not equal to, greater than 1, which implies y greater than equal. Why am I doing that? Greater than 0.5. After using Chebyshev's inequality for so long, writing greater than, equal to instead of greater than. So this is 1, right? This is 1. 2, we want y minus x plus 1 minus y greater than x, which implies, let's cancel out y on both sides, which implies 2x is less than 1, right? This implies y or x is less than 0.5 x. Now we have x plus 1 minus y should be greater than y minus x, which implies pulling y minus x to both sides, we are on y minus x 2 times y minus x should be less than 1, which implies x plus 0.5 should be greater, or rather let's write this around, y less than 0.5 plus x. So these are the three things which we have, right? Let's actually draw a diagram here where this represents the unit box, unit square, 0, 0, oops, 1, 1.